All right, here now.
There we go. Sorry. I remember Harrison at one point telling me that he didn't really agree with a lot of, or most of, I'm not sure. I'd have to ask him, Harris, H.S. Harris, on Hegel. On the other hand, I'm getting to the point where I'm far enough in my own reading in Hegel that I'm like, you know what? I'm just gonna try it. I'm just gonna use anybody I can, and then sort of like try to read it as best I can so that I can make my own judgment because there's only so many sources and Hoolgate's great, but Hoolgate also, unless you catch him in the odd article, I've noticed that he doesn't necessarily draw the conclusions so much as focus on the logic, which is a good thing to do. His focusing on the logic is something I really appreciate because so few other people do. Like he takes you through the arguments. Um, and so reading up on, and I'm talking about the phenomenology at this point, reading up on the clash of, the struggle for survival and the master slave dialectic. Um, Stern takes you through several different arguments for interpretation that have been made, and he sort of sums them up. And what he lands on, I believe, is one in which you don't have a complete picture because you're supposed to run into a contradiction that's not resolvable, right? And so it's not necessarily the interpretation that looks most complete that's the most correct, because if it was, then we would see the struggle for survival in its barest form around us every day, and we don't. That's not how we work. That is a, you know, um, I mean, it comes up historically, but it's much more complicated than just that shape. You know what I mean? So I'm still reading up on it. I have yet. I need to read the Hoolgate section on that part. I've already read Stearns, and um, it's good. I thought it was decent. Um, it's just that it's gonna take a couple of read throughs with Hegel to really get it. Um, I'm really beginning to appreciate how when Hegel spends the time before a section actually consolidating what the previous section was about, but in its immediate form in the new shape of consciousness. Um, he sort of he sets the rules up for the experiences that you're about to have or consciousness is about to have. And at this point in teaching, my best advice to anybody reading is if you get confused, go back to the beginning of the section where he sums up the last section, and it should give you a clue. So, and I'm finding that in the philosophy of nature too. He, especially here, he loves to repeat and repeat and repeat. Um, um, what was in the previous section. So that's good. All right. So, Kepler's laws.
Okay, got it.
And
Yeah, I think one thing that made this make more sense to me in the way Hegel's talking about stuff is like how space doesn't double itself in falling, but does in Kepler in the free motion. It's literally a vector, but it's a concrete vector instead of an abstract one because that is space, but it's in terms of falling, they're parallel to each other, so it doesn't combine with itself. But when it's orthogonal to each other, like one's pointing toward the sun, the other one's pointing toward its main trajectory, they're definitely double up on each other. So
mhm.
that makes this make a lot more sense. What he's trying to argue is it's measure. You can't just quantitative look at it quantitatively. Even this direction of space makes an additional qualitative aspect.
Yeah. So, just to present it to the audience and just sort of give ourselves a framework too, Kyle, go ahead and read 270 off the screen.
Well, I'd rather read in my book, but okay.
No, no, perfect, perfect.
Doubly. As regards the bodies in which the notion of gravity is freely realized explicitly, they have as the determinations of their diverse natures the moments of their notion. One body, therefore, is the universal center of abstract self-relation over against this extreme. There is that of immediate self-external centralist singularity, appearing as likewise independent corporeality. But the particular bodies are those which, characterize as well by self-externality as by being within self, are centers for themselves, and are related to the first mentioned body as to their essential unity.
Now, a question I have for you, and maybe this is me just taking a guess, but the language of this sounds an awful lot like self-consciousness coming up against another self-consciousness.
I
Maybe
haven't
that's,
read that part yet.
oh, okay, never mind. Um, all right. Okay, okay, never mind. So, what do you take from this, Kyle or Jim, first off?
Together,
Anything?
syllogism of universal, particular, and singular, where particular's the middle term. And it's
Yeah.
basically just saying that it's the particular bodies, which is characterizing these motions, are themselves both a center and have a center in the other at the same time. Which a planet is both, has its own moons, but of course itself is kind of a moon to the sun.
Yeah.
Yeah.
Yeah. Yeah. Yeah, you're right. And he gets into that later explicitly. Okay, so for those folks watching, this entire section with Kepler's laws basically has to do with the solar system and how it works. And Hegel doesn't go as far as trying to account for the motion of the stars. He basically says uh, in the previous section that, um, at least in his era, it wasn't as well measured or known as the planetary bodies. And so, really, all you can do for a philosophy of nature is to integrate the planetary solar system into the philosophical system, but not necessarily the system of the stars. Um, it isn't because the stars are just, holes in the roof through which light shines, right? He doesn't believe that. He believes that they are natural objects, but because, during his era, they weren't as well measured as this one, you can only say so much. And
Now
uh,
we can actually measure the star's direct rotation around the galaxy, and that, yeah.
and how hot they are and the whole thing. Yeah. So yeah, there is an extensive remark on the planetary bodies, but the long and the short of the remark is his extensive commentary on how Kepler derived the laws of planetary motion originally, and Newton, fortunately or unfortunately, took all the credit for it by putting it in a mathematical notation. And Kepler or Hegel talks a lot about that. He's very much a Kepler man. The first time I read this, I thought, okay, well, maybe Hegel's just backwards and doesn't really get it. But after reading this, you realize just how plugged in Hegel is to the science, and he can compare the two theories and see exactly where Newton took it and why Newton's taking a a set of particular empirical observations and trying to boil them down into what he calls forces, in which the force does not tell you backwards compatibly, I guess you could say, all the particulars of all of those empirical measurements and such. He says it's not the full picture. It gives you some of the picture based on particular things, but not it, Newton's not a good universal the way Kepler is in terms of deriving a law. I don't, Kyle and Jim, I'll let you take it from there
Yeah,
on
I
any
think,
of the details.
yeah, well, the great majority of physicists, I think, both back then and now, would side of Newton. Hegel, I think, was very much in a minority position, which I think he certainly realized he was. But part of it was, I think, because Hegel also had a critique of the concept of force, which probably seemed an eccentric view at that time, but is actually now widely accepted among physicists, even though they don't. Most physicists, I don't think, would trace that critique back to Hegel. They would trace it back to people like Hertz and Mach, but the critique of the concept of force is basic to like Einstein's general theory of relativity.
Yeah, because what, like in phenomenology, he brings about force as like, oh, it's just sort of this inner thing that does this outer force because we can't perceive it directly. But then you start to get out, well, which is the actual true force? That's just why we got centrifugal and centripetal law
Yeah,
forces here,
yeah,
as sort of which one's the source. Not they're both are at the same time, yet neither are. And then so there's a law that gets derived out of that, which like is the dual law, the dual forces, which I'm trying to remember exactly how he proves it falls apart, but basically, yeah, it's just sort of this continued inner that you can't know. And it's just sort of like, oh, because it also does it just by trying to explain something, it merely describes something from that side, and then he does get a lot more into that in the commentary section. You, I didn't get to complete the commentary section today, but man, you really started laying into Newton.
Yeah, yeah. The remark goes into a lot of that, and it's funny because he even recognizes his own limitations, right? Like he says at the bottom of this page, I shall not appeal to the fact that, moreover, an interest in those subjects has occupied me for 25 years. So he's basically saying, as much time as I've put into this, I don't claim to be an authority on all the particulars of the natural observations that there are. As much as I can be, I represent that, but it's actually kind of cool. Um, I don't know, this whole section, like I mean, I read a bunch of this, but once I got to the Zusatz, I started sort of skimming because he starts going into Euclid like ruminations on circles and ellipses and conic sections and the whole thing of
Yeah, that's how they
planetary mechanics.
to describe the kind of form because you can slice the cone and get this circular or cyclical related shapes.
Yeah.
And that's all it really
Yeah,
means.
in study mechanics at in college, they they use differential equations to describe what's going on, and the solutions to those equations are conic sections, which could be ellipses, circles, or
Mhm. Oh,
could be
Hmm.
hyperbolic hyperboles. Yeah,
Yeah. Um, let's see here. Yeah, he says, in the first place, the motion in general is one that turns back into itself. Um, lies in the determination of the bodies of particularity and singularity generally, that is, that of having, on the one hand, a center in themselves and a self subsistent existence, and also at the same time having their center in another than themselves. So basically, exactly what you said at the very beginning. The Earth rotates and it has a center of gravity, but it also follows a center of gravity that's outside of itself in its rotation around the sun in the ellipse. And then he says, these are the determinations of the notion which underlie the conceptions of centripetal and centrifugal force, but they are perverted into that form as if each of them existed and acted independently on its own, apart from the other, and as if they encountered each other only in their effects, only externally, and consequently contingently. This description, I think, is very, very good, because if you think about how Marx handles capital and the commodity in both its use value form and its exchange um, form through value. I think that's the center of his critique of the commodity fetish, is that we look at the commodities and we can only see them as acting independently on their own, right? And in one and the same object, right? And here he's saying that one and the same object, the planets, right, um, are seen as a play of forces that are actually a show when they're actually all one motion, right? Just one. And I love this description because I seldom come across something so plainly put. And this is in Hegel in the original text too. It's not like it's like an interpretation. So I find that very gratifying that this description of a dialectic. Um,
yeah, it'd be interesting to see if the Soviet textbooks on mechanics go into this or not. I don't know. I don't have any. I have Soviet
yeah.
textbooks on quantum mechanics, but not on classical mechanics, so I'm not sure how the Soviets treated that.
Sorry, my coffee's still brewing and the kids are still up.
Oh, I might have just found a copy for you.
Oh, did you? Nice. All right. Please share it.
Um,
Please share it on the website or
Institute
the.
of Physical Problems, USSR Academy of Sciences, course on theoretical physics, and it's supposed to talk about mechanics. Yeah, Kepler's problems in here. Yeah.
Mhm. Yeah, he is acerbic in in this remark. He says, in this so-called explanation of the uniformly accelerated and retarded motion by the alternate decrease and increase in the magnitude of the centripetal and centrifugal forces, the confusion introduced by the assumption of such self-subsistent forces appears at its worst. And he details it and shows you how it contradicts the tendency of an object in motion to remain in motion, and an object that is not in motion to remain not in motion, and so on and so forth. What is that? The law of the it's like a tendency or law to remain at its present inertia, right? And this idea that you're going one direction and then you have a sudden reversal, right? Just out of nowhere, just because that's what happens. Uh, I think that's what he means by at its worst, just god awful reasoning. um, and it, I think I think it comes down to centering um, the quantitative to try to build up a qualitative picture, because you lose. I'm trying to think through this. You're trying to build up a picture of the universe, but you start with mathematics, and you get a certain distance, but then it starts to break down. It's like measuring the different organs and then trying to tell people how they all work in the body, right? Uh, it just doesn't work seamlessly, and you have to like contrive these transitions, like the sudden reversal, in the ellipse, between um uh what's that word? Centrifugal and centripetal motion. Like, how do you account for that? Well, they do the best they can, but it just doesn't work. They make the math work, I think. Somehow they make the math work, but when you try to picture it, it's this sort of topsy-turvy world, I think, and that's what he's getting at with um, the explanation being at its worst. Okay, so there's that. Um, like I said, I just wanted to highlight a few things in here. People who are reading along or who may be watching, we're not exactly going to give you a full class on how all of this stuff works. Just sort of trying to hit some of the highlights. He says the abstract determinateness that constitutes the circle manifests itself also in this way: that the arc or angle contained between two radii is independent of them, is as regards them a purely empirical quantity. But in motion, and here's his point, in motion, which is determined by the notion, the distance from the center and the arc described in a certain amount of time must be embraced in a single determinateness, must constitute a whole. Thus, we have a space determination of two dimensions, the sector. Right. So he's kind of going through um, how you can get a much better picture when the moments are sublated.
I think that's what I was referring to earlier too, is that they're taking purely empirical quantity, but actually taking them as they wholly are.
Yeah.
You get the whole fact that space reacting to space is not in the same direction, so the spatial quality is also different. And since this is where we get the square of space. Yet the determination of space by time appears as a determination of two dimensions as a plane. It's connected to what we said above about the same as displayed in the motion of falling. Yeah, this is where I got all that.
Learning. I'm still going to school, honey. That's what this is. So let's see. Now, I'm really interested in how he accounts for laws. Um, so, like here, he says this law concerns only the relation of the arc to the radius vector, and here time is an abstract unity in which the various sectors are realized because it is the determinate as a unity. And he goes on, but I'm also conscious of how he just sort of enumerated what law is and what limits law has within the phenomenology early on. And I find myself sort of rocketing back and forth those two ideas because at the same time that he at the same time that he honors Kepler's laws, he also keeps in mind that the law is only as good as what it accounts for, as a form, it has limitations.
They say right there, but in absolute motion, the realm of free measures, each determinate attains its totality. Which is what I was saying earlier. Yeah, that
Yeah. Isn't that
because
something?
yeah, because time relates only to itself. It only it contains no dimension, so it's just yeah. Well, one thing that so I'm still not quite sure of what he means by the quadricity of space.
Yeah, he was talking about how Kepler was trying for like 25 years or something to derive a certain law, and it took him that long, basically because he made a math error or something or
Yeah,
other. Does that sound about right? Was that in the Zuzats or somewhere?
yeah, and I do
Or was
remember
it?
that also historically as well.
Yeah.
Yeah. And I'm actually reminded by that remark of Marx talking about Aristotle and how Aristotle was not able to derive value the way Marx was. Although I think you could say that with Aristotle, the material just wasn't there to derive value in the way that Marx did. Whereas here, Kepler, you know, uh, he's working with medieval instruments, and so you do the best you can. Um, yeah, I love this. He says, to elicit the universal law from these isolated phenomena is the work of genius in this field. Like you really, really have to be dedicated to your craft. And this I found really cool. The next sphere in which we find laws, yeah, laws mean the combination of two simple determinants, such that merely their simple interconnection constitutes the whole relationship, and yet each must have the show of freedom in regard to the other. And if you're wondering what the show of freedom means, it basically means that this law pertains no matter what particular instance of what the law is supposed to cover. You have the whole range of motion, right? Of what whatever uh, object. And then he says the next sphere in which we find laws again is spirit, because there we have self-subsistent entities confronting each other. Now the laws of this motion concern two things: the form of the path and the velocity of the motion. The thing is to be done The thing to be done is to develop this from the notion. This would give rise to a far reaching science, and the difficulty of the task is such that this has not yet been fully accomplished. Laws pertaining to the spirit. I'm really interested to know what he means exactly by that, because at first I think he means sociology, and then you have this sentence about the path and the velocity of the motion. And I'm trying to think of the self consciousness who is faced with another self consciousness. And I'm trying to square the two, and I'm not sure if I'm doing that right or not. Probably not. Yeah. Sorry. Um, so in this section, and there's like 10 pages of this, he goes into um, in the sphere of mechanics, a long-winded theory of the solar system. And he talks about Copernicus driving what's going on with the circle and the ellipse, planetary motion. And I got to be honest, I did not read the whole thing through.
Well, there it is. If you don't, there it is. You highlighted it.
Oh, yeah, there it is. For 27 years, Kepler sought, we were talking about this earlier. Kepler sought the law that the cubes of the mean distances of the different planets are proportional to the squares of their periods of revolution. Had it not been for an error in calculation when he was quite near to discovering the law, he would have discovered it earlier. He had absolute faith that reason must be there, and through this faith, he arrived at this law. Now, here, I think, is an item of interest for all who want to read this book, but wonder what it means for material reality to have reason in it. Okay. When you're looking at Kepler's laws and how he calculated um, uh, the different particulars, and then yet was able to derive a law. This is what Hegel means. Okay, when external reality has reason in it, it means that human beings have derived um, reliable laws by which to describe space in and of itself, planetary and star motions and the whole thing. And reason has ordered it for us to where not only do we have our view, our phenomenological view of the universe, but we also can see it in and for itself, quite separate from whether we were there or not, right? And that's what he means. It's really quite elegant to put it that way, I think. Let's see. See what he says here. He says, at first, the thought that the planets stood in an imminent connection with the sun was not present in Newton's mind, although Kepler already had it. It is absurd, therefore, to cite this as a new conception of Newton's. Yeah, once again, he's attacking Newton, um, which I find quite gratifying, actually. Just the way he puts it. Um, what did you find, Kyle?
Oh no, I was thinking this earlier. Just I found actually no. If we look at those equations, I kind of skim through it. I'm trying to understand what he's trying to do, but it kind of looks like by going through where it looks like it's doing the same thing with uppercase and lowercase equations, that might just be like, hey, here's identity, and here's an identity, and here's an identity, and here's an identity, and oh, look, I proved gravity. I think that's his arguments there. Is that Newton just goes through a series of identities that just leads to nothing new.
Yeah, it's edification. It's explanation, which
It,
we were talking about in
yeah,
Force and the Understanding.
it's actually a description, not a
Yeah,
explanation.
yeah, yeah. That's what's helpful here with the phenomenology is he actually goes through and does a critique of the concept of force, and that coupled with this critique of Newton versus Kepler, it's made perfectly clear why Newton's law is so unsatisfactory.
The necessity expressed in the law is nothing other than the simple identity of the movement with itself, which does not progress at all.
Yeah.
Which literally what I just said earlier. So
Yeah.
yeah.
Yeah. No, no, absolutely. It makes me realize that you can't really like prioritize one part of this system of his over the other because it's all tightly interwoven. It's all the same, okay, in terms of its continuity. And I think that's how he meant it, was that from beginning to end, you know, you would be able to
There are things that you can predict on from Newton's law of gravity that you really cannot easily predict from Kepler's laws, like the perturbations of the planets. You
yeah.
There's really no basis for that in Kepler's laws, but with Newton's law of gravity, you can calculate how large these perturbations would be.
Yeah,
Yeah,
he mentioned something like that
Yeah,
in here. Yeah. So too, the assumption of an acceleration directly implies a difference in the radii. Arc and radius are inseparably connected. The path must therefore be an ellipse, for it is a motion which returns into itself. Observation shows that even the ellipse does not exactly correspond to the path of the planets, and so other perturbations must be assumed. It will be for future astronomy to decide whether the path has not functions more profound than the ellipse, whether it is not perhaps an oval, etc. So basically, all he's saying is that basically all I take this to say is that Kepler was able to derive a more universal picture, but he didn't have all the facts that Newton did in empirical observation. And he didn't have what we have, right? And so he's saying that there's still an element of contingency in trying to make a whole picture the way we want with the philosophy of nature. It's going to be necessarily incomplete conceptually as long as there's contingency out there. And there's always contingency out there that we have not accounted for yet. Yeah. And that's one thing that we should probably get used to because every time something, if a black hole decided to travel through our solar system at, perpendicular to the what is it called? The plane of ecliptic, right? Just zoomed down and had a whole bunch of effects. We would have no way of figuring out systemically just from the picture that we have of the solar system to account for it. We would have to theorize an object that is on less of a solar system plane and more of a um uh what would you call it? Like
intergalactic,
yeah, galactic astrological uh scale in order
astrological.
say I'm so sorry. See that's the kind of day I'm having.
That's all right.
Astronomical.
It's funny.
No, yeah. But yeah, you know what I mean.
Yeah,
It's
astronomical. Yeah.
it's a larger system than just the solar system, and so you have to square the solar picture with the galactic picture, and then you're able to derive, you know, what actually happened and turn it into a law, which has to do with, I don't even know what kind of law you would have. We probably already have the law. Universal gravitation
Yeah.
probably covers it. It's just that you've got to be able to show it at a galactic level with all the stars,
Yeah,
and
it's
and then you're fine.
the three body problem onward. Yep.
What is the three body problem? I keep hearing that as a title of a book.
Well, I mean, the real thing is pretty much how complicated it gets when you try to do the universal gravitation using Newton's laws with three bodies. It becomes
Oh,
chaotic
oh,
immediately.
is it just with two in normal equations?
Yeah, Newton's law with two equations, it's fine. When you start doing three, especially of course, at this point, it's Einstein's equation, but you start using three body problem,
Yeah.
you get chaos. And we're talking about this like in a mathematical sense. It's very, or like in a scientific, it's very much hard to predict. It's, like the chaos theory thing is how if a bird flaps its wings in Brazil, we get a tornado in the Great Plains. It's very small changes lead to very unexpected differences.
To me,
That's
it
dialectical
sounds
too, but
well. Here's the thing. Chaos theory to me has always sounded like static. Like you don't really know what's going on, so you plug things in as if it makes sense to plug a third body in, when in fact, um, it's more a case of bad information in, bad information out.
they may have found a pattern behind chaos theory actually as of this year. So,
And they may have. Um,
but yeah,
I'm just like,
it's
if it's a question of measuring between two bodies, and then the third one is not part of the system of the first two, just as an example, based on what we just said, there would be a way to
mhm,
not have it look chaotic and static, but you would have to square the two systems to each other.
mhm.
Um, and I admit that that is hard to do. Hegel does not attempt to try to do that here in any sense of the word. In fact, he even says, look, I can't account for the stars and their movements on the galactic plane because I don't have powerful enough telescopes. So we're not going to make that part of the philosophy of nature. That is not to say that they're, again, the stars are just holes in the sky through which light from heaven seeps through. It's just that we can't go there yet, but when we can, we'll be able to do exactly what I suggested. I know I sound like a broken record. Sorry. A lot of Hegel is like that. He tends to repeat points in different lights, especially as he goes up the dialectic to parallel points, like we were talking about before, Kyle. It almost feels like deja vu when he does that. Um, yeah, lots of math. Basically, he's going through Newton and Kepler, and he's going through it with a fine tooth comb. And the impression that I get when reading through this is that anyone who tries to accuse Hegel of being anti-science or being archaic really didn't read through this stuff and realize that he took lots of notes and was able to talk about it intelligently. Sorry. Um,
Yeah, I swear a lot of this is like calculus where you did like 40 pages trying to defend it, but it really didn't need to be read. That's how I feel that most of this is.
yeah, yeah. I'm um the the part at the end I found really awesome. So I'm going to read this out. He says, "Philosophy has to start from the notion, and even if it does not assert much, we must be content with this. The philosophy of nature is in error when it wants to account for every phenomenon. That is what happens in the finite sciences, which try to trace everything back to general conceptions, the hypotheses. In these sciences, the sole verification of the hypothesis lies in the empirical element, and consequently, everything must be explained. But what is known through the notion is clear by itself and stands firm. And philosophy need not feel any embarrassment about this, even if all phenomena are not yet explained. I have therefore set down here only the rudiments, 10 pages worth, of a rational procedure in the comprehension of the mathematical and mechanical laws of nature as this free realm of measures. This standpoint I know is ignored by professional astronomers, but a time will come when this science will require for its satisfaction the philosophical notion. I tend to agree. And I think so did some of the Soviet scientists who wrote at the time. I'll be right back.
Yep, I really need to go back through
Talking.
the anyways. Hmm. Didn't really they know about Ceres this far back in history. All right.
All right, I'm back. I'm not really going to belabor anymore on the the
Kepler.
question.
Yeah, because this is him getting into a
Very technical.
way describing mechanics through proper notion. Yeah.
Yeah. Now, as he refers to it, which I'm sure he will in the rest of the text as he accounts for motion itself, I'm sure he will sum up in his usual way what the moments are. And we've already read what the moments are in the main text. And so as long as we keep those in mind and basically just know that this is him accounting for motion and the motion being I guess you could say a property of the bodies in their gravity, in their mass, in their their self-generating effect on the rest of the universe, so to speak, I think will be fine. Um, so now we're looking at the transition of physics, and I want to see. Actually, didn't I say we should read the transition to physics too? I
Yeah.
don't think I did.
Yeah, I didn't either, but
Yeah.
right now.
Well, I mean, I tried to read the Zusatz and just sort of like
I
sung
think
myself sung myself to sleep a little bit.
this is also where the one chapter in the intro, Holgate's intro, stops, right? With Newton, his critique of Newton. And then there's the next section where it goes in organics. I think we're kind of just saying, hey, we may be kind of needing the other nature book for
Well,
any.
that's the thing, because Houlgate's article in the New Nature book that just came out is
Yeah.
on physics.
Oh, there we go. I forgot about that.
Yeah, his hang on, d- don't get me lying. I got it right in front of me. Um, Logic and Physics in Hegel's Philosophy of Nature. So that's page 176.
You'd like to know what he quotes, but
Yeah.
247, 249.
Yeah. So so he talks about philosophy, science, and experience, talks about from logic to nature. Um,
Oh, he does. Okay.
and then he does the task and method of Hegel's philosophy of nature. And then he starts talking about the philosophical physics from light to the elementary process.
We care about. Wait, we're at 253, 271. Okay.
I'm not sure.
No, he does pretty much go straight to that point and then slows down. Yeah, so he does.
Oh, wait. Are you looking at the introduction?
No, the introduction stops about where he picks up in physics later. So,
There, yeah, there we go. So, um, Yeah, I mean, if he wanted to write his own like standalone book on philosophy of nature, I honestly think he could do it with just a little more work. He's
He's
probably
almost there.
yeah, he's got one and two, and now he just needs organics.
No, he does
Uh,
have organics. That's where he
oh,
picks
he
up
does.
the next chapter. He skips physics
Okay.
and the
Yeah,
introduction.
yeah, there it is. And this is the work he's been doing. So from specific gravity to chemistry in the last section, and then he talks about the problem of light, and that's it. And you know, and there he goes. So yeah, yeah, that is kind of cool. So for our reading for next time, let's read Transition to Physics, which is just like it's not even a it's not even a full page, right?
Enough of with
Right.
commentary.
Yeah, and then we go into section two, physics, and um, the free physical bodies, and then he starts in on light. And let's see how long light is. Hang on just a second. Um,
And as it's looking, this is where meteorology comes in.
yeah. Uh, I'm, would you guys mind it terribly if we read 20 pages from transition to physics up to B, the elements? It's only about 20 pages, and it goes through the first part of physics, where he talks about light. And really, it's the free physical bodies that is the main chapter of what we're going to get. So from page 83 to 105. Does that sound good?
Mm-hmm.
Okay.
Where is oh,
Yeah. And I will try to do a little extra reading and try to reread that entire article from the new book because he does go into explaining light. And so we can probably sit down and have a real powwow on what it actually means within Hegel's system, as opposed to just sort of what we did today, which is stumble over Kepler and Newton. You know. All right, comrades. Thanks very much for your time, and we'll see you in a week.
thanks.
Take care.
As always. Yeah.
As always. Yeah.